Well, hello and welcome to another Skipper Scott video. Today we're going to talk about the SS Minnow desktop. It's a powerful desktop with low power consumption, and it's running on a Raspberry Pi 4B 8 gigabit. So low power consumption is important when you're boating because you're sometimes running off of battery power and sometimes you need a working desktop. So we're going to demonstrate some of the power of this low power consumption system. Currently I'm using a draw.io site, and this desktop that you're viewing right now is actually running on this Raspberry Pi 4B 8 gigabyte that you see in this diagram from draw.io, and connected to it is a Logitech C920S webcam, and I'm currently using that microphone. I'm also using a simple screen recorder to record my screen, which is using the microphone through the Logitech C920S camera. Audio output that I'm doing is through Bluetooth, and it's going to the Bluetooth stereo. I can also plug my headphones into this LG22 IPS display, or the Sunfounder monitor, as it delivers audio through these HDMI connections that connect to these monitors. I can also plug my headphones directly in here to the Raspberry Pi, as it has an audio out port as well. And coming into the Raspberry Pi to power it is micro USB-C with a 12 to 5 volt converter and a 3 amp fuse and an on-off switch that connects to the boat RV power source. Likewise, this big display needs kind of its own power, and so it's got a 1 amp fuse and it's got a 12 to 19 volt inverter that then goes in and powers this display, and then it takes the HDMI from the Raspberry Pi 4B 8 gigabyte. In addition, this video that you're currently watching, I'm using a program called Shotcut, and I'm using that to edit this video and put it together and upload it to YouTube, but we'll talk about that in a future video. So now I'm going to move on to what is it going to take to get Ubuntu on this system, and make the tweaks to get Zoom running in a way that can be used as a desktop for online conferences and actually getting some work done. So in order to start the installation of our SS Minnow desktop system, we're going to want to put Ubuntu on it, and in order to do that we're going to have to use the RPI imager. And the RPI imager comes in multiple flavors. It's Ubuntu on any x86 architecture, Windows, and Mac OS, and if you're using a Raspberry Pi OS, you can do an apt install RPI imager. I happen to be using the Ubuntu operating system on the SS Minnow, and so I have to use snap to install it. So the command to install it here on the Ubuntu system is sudo snap install RPI imager, and that will get the RPI imager onto your machine. Now once you have the RPI imager on, you need to put some media into your USB port, in preferably a micro SSD card, into a USB reader that you can then plug into your computer. We want to choose an operating system, and we want to choose the other general purpose OS and Ubuntu, and then we want to choose the Ubuntu 2104 RPI 4/400 and the 64 gigabit desktop. So we're going to choose that one. And for our storage, since we're doing this on our own Raspberry Pi, you want to make sure we don't choose the internal SD card. That's where our operating system that we're running on currently lives. We want to use instead our USB connected mass storage, and we're going to select that one as well. Then we'll click right and we'll wait for this to finish, and as soon as it finishes we're going to do some additional configuration. Well, after we burn our image and insert it into our Pi, boot it up, and enter our initial usernames and passwords, we're going to want to go into a terminal, and we're going to want to edit a couple of text files to get our video and our audio configuration the way that they should be. So the first thing we're going to want to do is, in the directory that controls the firmware in our boot/boot/firmware, we're going to want to edit the text file config.txt. We're going to want to sudo and change to the root user, or have super user privileges so that we can modify this file and write. The things that we want to make sure are on, which this appears to be on by default, is DT param audio on, and that appears to be on by default. The one thing that does not appear to be on by default is this right here, DT overlay VC4-FKMS-V3D. Now this is important because we want to enable full KMS graphics overlay, because this is what's going to give us the video performance. Also, we're going to set our GPU memory to 128. According to the doc, we can set this to 256 or 512 if you've got the 8 GB version of the Raspberry Pi 4. I'm setting it to 128 because I want my memory to do other things. Also, we can set some max frame buffers, and then also enable 4K 60p on our HDMI so that we get some nice throughput on our video screen. That should get us squared away for the video screen, and then for our audio, to make sure then and cure a problem with our choppy audio when we're doing our conferences, we're going to want to edit the file /etc/pulse default.pa. And what we're going to want to do is we're going to want to go down and find the line where we are loading our module for the UDEV detect, and we're going to want to, it's going to look like this, load module UDEV detect. We're going to want to add this little bit, this tsked equals 0 to the end of that, and then once we're done, we'll reboot our machine, and we can do that. Let's see, we'll do a power off log out, and we'll reboot our machine, and we'll be back as soon as the machine boots. After we've rebooted our system and opened a terminal, we're going to do an apt update just to make sure that we have the latest lists of everything that we can install on the system. And this is installing and checking on an ARM64 architecture or a Raspberry Pi. Packages are all up to date. So now we're going to also use apt to install the Chromium browser. And we've already got, and so here it is, installing our Chromium browser, configuring our packages. And our apt install is actually calling snap. And now that we've got our Chromium browser installed, we'll be able to join a Zoom meeting. The reason we're installing Chromium is because with the Firefox browser, as I saw in multiple forums, was if you try to run it in a browser with Firefox, it takes over 100% of the CPU and effectively locks the machine. But with the Chromium browser, it appears to work just fine, and I can share screens, and the audio works and the video works, and it's pretty smooth. I can also do other things on the desktop while I'm in a Zoom meeting, and it doesn't affect my Zoom. So we're going to next create and join a Zoom meeting. Well, now that I have my Chromium installed, I'm going to join my Zoom meeting. And it's going to ask me to start the Zoom client, which I don't have a Zoom client. So I'm going to hit cancel, join from my browser, and we'll start the Zoom meeting from the browser. And as it comes up, it's going to use the webcam. Right here, which is the Logitech C920S USB going through our SS Minnow desktop. And as you can see in the bottom window, I'm joining from the desktop sitting right next to me. So here we are, I've got 2 participants in the meeting, and we're sharing video, we're sharing audio. can actually join the audio here, which I'm not going to do because we'll get feedback from the two machines here. But the two machines are connected via Zoom. I can also share my screen and share my entire screen, or I can share particular windows. This will do a mirror effect, or I can share different tabs in Chromium. Thanks for watching. Be sure to subscribe to our channel for more low-powered, high-performance computing.